Hello, this is Ruibin Chen, and this video shows my solution to question 1 of homework 6. Firstly, the question given the joint the joint density function of xy, which is equals to 1 plus xy divided by a, and also given the domain of x and y, the absolute value of x is less than 1 and the absolute value of y is less than 1, 2. Also, the joint density function equals to 0 otherwise. The first question needs us to find a so that the above defined is a valid joint density function. Therefore, the integral of the fxy dx dy should be 1. It's like this. Next, because a can be separated and divided separately, so a is and we can rewrite the formula to this, and the integral of the 1 plus xy dx dy is equals to 4. Therefore, 4 divided by a is equals to 1, and it implies that a is equals to 4. Secondly, it needs us to prove or disprove that xy are uncorrelated. To prove or disprove the xy are uncorrelated or not uncorrelated, we should check whether the expected value xy, whether it is equals to expected x times multiply the xy. Therefore, the expected value of xy is equals to xy integral of xy multiply fxy. The final value is equals to 1/9. And next, to calculate ex, the expected value of x, we calculate the fx, and because the expected value of the x is equals to integral of the x fx, the fx is equals to integral of the fxy dy, and we find that the fx is equals to 1 divided by 2, and hence we can calculate the ex is equals to integral of the x divided by 2, and because x is a odd function, the expected value equals to 0. Hence, we find that exy is not equal to ex multiply ey. Therefore, they cannot be uncorrelated. They are not uncorrelated. The third question asks us that whether xy are independent. The independent, we need to check whether fxy is equals to fx multiply fy. From the question 1, we found that the fxy is equals to this value, and the fx is equals to 1 divided by 2. Also, the fy is equals to 1 divided by 2 because they are symmetric. Therefore, it's easy to see that fxy is not equals to fx multiply fy. Therefore, xy are not independent. The fourth question asks us to find the joint density function of x squared and y squared. Let's assume that z is equals to x squared, y is equals to w is equal to y squared. Therefore, the Jacobian is equals to this matrix, and that is equals to 4xy, which is 4 square root of z and square root of w. And it can be implies that x is equals to positive or negative square root of z, and y is equals to positive or negative square root of w. Hence, we can calculate the joint density function of z and w, and z is equals to x squared and w is equal to y squared. Therefore, the joint density function is equals to fxy divided by absolutely of the joint factor, which is equals to this. And we can find that finally the result is equals to this. The joint density function is this, and it is easy to, and we can also imply that yes, the density function is this. The fifth sub-question asks that to prove or disprove that x squared and y squared are independent. Firstly, from the previous question, we can get the joint density function of zw, which is z, where z is equals to x squared, w is equals to y squared, which is equals to 1 divided by 4 square root of z and the square root of w. And we can separate them and divide into 2, and it is easy to see that the density function of z, the fz is equals to the 1 divided by 2 square root of z, and also the density function of the fw is 1 divided by 2 square root of w. So it is equal. The fzw is equals to fz multiply fw. So x squared and y squared are independent. So now the question 1 has been completed.